too. So you guys are all in the top line for some reason. So, go ahead, Tanya.
Hi, I'm Tanya Kesterly. I'll try to keep this brief. I'm a trained bioinformatician. I worked for Zach Kohani, who actually introduced me to you, George. So I was analyzing genetic data back in 2004. It's basically what I do. My mom was diagnosed with an extremely rare extraskeletal osteosarcoma in her retroperitoneum in May of 2020. I had no idea I really didn't know much about sarcoma. I told her, yeah, cancer's not a death sentence anymore, you'll be fine, because she was super healthy, 65-year-old, and it took her 9 months. That said, I really pushed for, she was treated at your facility, and you gave her a few months at least. It was palliative radiation, basically. But she had a very good response. She had 95% tumor necrosis. We really thought we had more time, and it had just shed cells probably before the treatment even started. That said, I had friends in the industry that were able to get her tumor sequenced while she was still alive. Out of Semaphore, they did a whole exome sequencing, whole transcriptome sequencing. It didn't really show much beyond what the foundation panel showed. However, as a scientist, I know that this data is highly valuable. I only know about 350 or so cases in the literature. I've struggled to get anyone to do anything with this data. I was surprised her oncologist or her team didn't want to even do a case report because it's so rare. I refused to let her just kind of die, another statistic, right? So I talked to the Broad Institute. I'm trying to get her data maybe into the Count Me In project. There's a pilot project going on there. I don't care if I have to publish it myself at some point. I want it to be open, available forever, long past I'm gone, right? So I promised my mom somehow she would help other people, especially children with this like osteosarcoma. There's got to be something they can glean. So I'm asking, I guess, for any leads or guidance or what you'd recommend I do with this data. And as someone that wants to help with not only, monetarily, but I have a highly skilled, network of Boston bioinformaticists I've gotten to work with the best. And I run a consultancy now.
So there's a lot of technical terms in that for those who aren't, PhDs in bioinformatics. Let me just say that a very sophisticated amount of analyses was done on her mother's DNA. And that can be, so much information. It takes up a lot of space on computers. Frankly, the most efficient way of saving a lot of information is in DNA. It's a very, very efficient way of coding information. Your point is well taken. I actually think you already found the solution to what you're asking. This Count Me In project, if those of you here have not heard of it, it's something we at Dana-Farber started with the Broad Institute. And Dana-Farber really is the cancer engine for the Broad Institute. And Count Me In is now sponsored by Steve Jobs' widow and the Emerson Collective and things like that. Because what we're trying to do is have a place to store information about any patient who volunteers to donate their data, to share their data. Because I think most patients in America, and frankly, most senators and representatives and presidents, they all think we're using all this data for research, and nothing could be farther from the truth. We're not good enough as a country, and no other country is better than us, really, about sharing such complicated data. But the infrastructure doesn't exist to share it and make sense of it. Now, in a lot of cases like extraskeletal osteosarcoma, the DNA just doesn't know what to do with itself, so it makes a lot of noise. And noise that's not relevant is hard to detect, right? Noise is noise. But there might not be much signal in that noise, but that's what we can't tell. So you can waste a lot of time looking at noise and trying to analyze it like you're trying to hear a melody in a John Cage recording, which is, to me, difficult to listen to. So the bottom line on that is the Count Me In initiative is really a philanthropically driven thing, so patients can donate their data, and a big, large-scale effort, especially in rare diseases, but also in breast cancer, also in colon cancer, common diseases, where people can put data, and eventually people like you, Tanya, bioinformaticists and biologists, can look at it and say, can I make sense of this in any way using some new algorithm or some new computer? Or is this just noise? Is this just a confused cell and there's really no signal in the noise? We don't know. But I like the Count Me In, and that's what I think Count Me In is doing. It's why we do have a big federal grant to also support that, some $20, $50 million that the government is giving to support that, in addition to philanthropy. And we're proud that Dana-Farber helped get that started. But thanks for raising that, Tanya. We're doing our best to try to make data open source and encourage that kind of collaboration.
Okay.
Part of the problem with open source, as you well know, when you store data, even if it's just on the Amazon cloud, somebody's got to pay for it to live there, right? It's about money.
Yeah, and luckily, luckily storage is very cheap these days. It becomes the analysis that's computationally very complex.
Exactly.
But yeah. I just getting those patient samples is just huge because I don't want my mom's data to just be forgotten about and disappear into the ether, right? So I'm sure eventually we'll have enough to get some answers.
Thanks for bringing that up.
Thanks. I'll pursue that.
Okay, Sean speaking. Hello there.
Hi. This is a broad-based question. There was recently a study on